Okay, I figured that's enough time of waiting. Alright, okay. Welcome to part 5 of Card Sorting Robot. In this part 5, we are simply gonna do just a little bit of designing a mechanism. You see, last stream number 4, I had spent around an hour and a half maybe trying to figure out a mechanism to keep the grabber mechanism up. So let me explain what that is a little bit. I'll draw it out in my trusty Microsoft Paint. All right. Basically, we have our suction cup, right? And then we have our cards, right? So that's our cards. And our suction cup needs to grab the card, of course. That's what it's for. And so to do that, it needs to go up and down, right? I mean, obviously. So it goes up and down. And this is the attachment. But if you do that, then when it goes up, it will grab a big chunk of cards, and then they'll plop down, like they might plop down after the suction cup moves, which is problematic to say the least, right? Because then that's where you get jams, and that's where you get cards being flipped, and that's where you get damage, and you get messed up everything. It's not good. So what we need to do, we need to figure out a way so that we only pick up one card with the suction cup. Now, if you've seen the other streams, you probably know where I'm going, right? We have a bender. Basically, how it works is you have this sort of doohickey, and it's attached to the suction cup. So this goes like this. It's like a big H. And then the suction cup mechanism is on the inside. Like this slides, and then there's the suction cup. And it holds on to the suction cup, right? Like that. And then this is the suction cup. That's what it looks like roughly. And so what we need to do is no, sorry, I never finished explaining this. So basically what happens with this is that once this entire thing approaches a card, right? The suction cup is still able to move up and down, but this outside H section stays in place. So eventually it will look like this, right? Hello, 2HU fan 21. Eventually it'll look like this, right? With the H being like that. And the suction cup flat on the card. And so what that means, so that's pretty simple, right? And then we just have a spring. So when the suction cup goes up, it bends the card. Maybe that's a bit of an exaggeration, but let me draw the H yet again. But basically what happens is when we pick up the card, the H presses down, which bends the card, and that keeps it separate from the rest of the stack, right? Because of suction, air, maybe a little bit of van der Waals forces. I highly doubt it, but it could be a factor. I don't know. But either way, this part is pretty simple. It's a simple rubber band, right? And it just does it by itself. However, there's one slight issue where this happens, and it's detrimental to the operation of the machine. And it happens when we try and take pictures of the cards. So what's happening when we take a picture of a card? And why is this an issue when we take a picture of a card, right? So the way we're taking pictures of cards with this robot is, instead of having the camera mounted to this H, where it moves around and takes a picture from above, we're actually mounting the camera underneath one of the bins. So this is the camera, right? The camera is being mounted underneath one of the bins that the cards go into. Because this way, we don't need to have any complicated camera wiring on the H, which means we can move it faster and make it lighter, and it's just better in general. Also, our lighting is more consistent because we can block out all external light while within the bin, meaning that we can guarantee that lighting will be exactly the same every single time. However, once again, there's an issue here. Let's say we're trying to take a picture of a card, and we have our H in here, right? And it's gonna look something like this. Now, camera lenses, normally you'd look at this and be like, wow, that's a very flat image. And yeah, that is true. However, modern camera lenses are designed such that this isn't flat. It would instead make the card look something like this. And when we're trying to identify what the card is, that's not good. Meaning, somehow, we need a way such that when we're taking a picture of a card, we need to keep the H up out of the suction cup range. How do we do that? That's what we spent an hour yesterday, not yesterday, 2 days ago. We spent an hour yesterday trying to figure this out. And I still didn't come up with a good solution by the end. But I used the power of sleeping on the problem and figured it out the morning after. Wow, ain't that crazy? So it's actually remarkably simple. What you do, or at least what the plan is for now, is we're gonna be facing from this face. So it's gonna look like a square. But basically, we have a little bit of extra range. So the camera bin, so like these are the bins, right? 1, 2, 3, 4, 5. The camera bin is this one, meaning we have a little bit of extra space there, and we can also go up a little bit further. And so what does this mean? This means that we can have like a little doohickey like around here to like latch the thingy on. So that's simple, but how do we... I want our mechanism such that instead of having to go down, then up, then back, I want it to be a simple, very easy motion, right? Because that's faster. And remember, if we're doing this multiple thousands of times, every millisecond saved can add up. Like significantly. So ideally, we can just do this. And I think I have the solution for that. What we need to do is basically, let's say there's a channel here, right? And it will look something like this. It's very simple. It looks like that, and then up here, it looks like this. Now, this part is what is attached here. This is that. So, this will be mounted to the frame of the robot, right? And what we need to do, we need to have a peg inside of here that interfaces with this. You know, I think actually I'm wrong with this. I think actually it looks like this. Hold on, I need to remember because I conceptualized it, but I never wrote it out. I think it looks like this. No, I think it looks like this. Note that this space is open and this space, basically these two lines are on the same, axis. So, what is this about? Why am I doing this? It's simply so that on the bin, here's the rectangle, right? The rectangle of this face, remember? This is what I was telling you about. Basically, we can have a little cutout for the inside part that the suction cup is attached to. And so that means this moves separate from this. This part on the middle is the one attached to the linear rail, and it's also the one that is moved by the stepper motor. So this outside one is completely floating. It's just got a little bit of a spring on it to return it back down. And so what I realized is that if I have a sort of like, wait, hold on, I need to remember it. I figured it out and then I forgot. Right, I remember now. Okay, so let's say I had a sort of armature here, right? It will rotate around this point. And here there's a peg, and this peg interfaces with this, right? So you might be thinking, okay, so what? Now here's where the magic happens. Here, attached to the center, I have a sort of like lock on this, right? Meaning it can't rotate at all. This cannot rotate in this direction at all. This is blocked, right? And so what that means is that when it hits here, it'll get stuck, moving this entire body up until this goes all the way down to here, where it then does not lock based on the angle, meaning this is free to rotate into this channel. And then I simply need a like attached to the center point, like a like little dot there. Wait, hold on. I had this planned out and then I forgot it. Okay, so the force is going this way, meaning that, wait, hold on. I need to remember this. I really should have written it down. I had the entire thing planned out in my brain, and let's say I forgot it. Let me take a sip of soda, maybe that'll help. Yummy and healthy. Okie dokie. Let us remember. So let's just completely, let's ignore the entire like limitations of horizontal, right? I believe this is what I was going for. Hello, almonds, how's it going? Did you pay attention to my entire explanation? It's long. Anyway, here's what I was going for. I have a little doodad here, right? And the idea is that, okay, let's just have a hypothetical doodad here. And this doodad is attached to the center channel that moves up and down, right? Now, let's just say hypothetically this doodad just moves up and down with this center channel, right? So you got here about when I was here? Okay. Well, okay, so you didn't miss much because this is all just stuff I've been explaining before. But basically, my idea was that I can have like this armature here, right? And it pivots around here. That's the pivot. And basically the idea is that this piece will just block it. And then once it gets pushed down past here, this will be freed up space. And this dot can basically just go onto that. And this part that is really ugly would look something like this, right? So as it slides up and down, the hypothetical dot would be stuck over here, putting pressure in this direction until it gets up here where it can lock into place at the angle, right? Then once it's locked in place, then your entire bin, the H, stays up, right? So then, how do you get it down? Well, it goes back to this channel here. That's why I have this piece specifically. If somehow I can figure out the correct angle for here, I can ease this piece back out of this slot by simply moving upwards. Now maybe this is flat, maybe this just stays flat and it just stays in thanks to because like it's at an angle, right? If it's flat, we're we're gonna do a big hypothetical here, right? If it's flat, then where's the force vector from this trying to go downwards, right? The force vector, I don't know. I'm not smart enough to do this. I think it's a sine and cosine something. Maybe I do need the angle. But either way, the idea is that off of this part here, it will go into and it will disengage from this like angled section, go onto here, move down, snap down, because this is, remember, on a spring, and this will be slightly above. So it'll snap down, locking out from moving left and right, but this piece will catch it before it hits the card, preventing damage. That's the goal. Is it possible? I don't know. I don't know. I'm not, like, this is the concept that I had. I just need to put it into practice and see if it like works in theory, right? Now, another cool thing about this is that I don't need to deal with going further right than normal. I can simply do this by going more up than normal, right? Like if I normally stay at this height for just moving the cards around, then when I want to take a picture, I can just go up here, right? Or I can go up here, send it through this little channel, and then keep going down, right? And then it's fast, it's efficient. And then I can just go back up. Because when I pick up the card, right? When I pick up the card, I'm already moving upwards, making it very fast to just move a little bit more upwards. I just move upwards, and then I move over, and I move down again. But normally, I'd just be doing it like that, right? The only issue here is that how much extra space do I have at the top, right? Because like, how much of a tolerance did I give myself? I don't remember. I'm hoping it's reasonable. Is it reasonable? Maybe not. Maybe it's like, I'm hoping I gave myself 20 millimeters. 2 centimeters. That's a very small number. But I feel like I might not have. Because remember, this bin, the bin height that we are using right now is, it's 100 millimeters tall. And our linear rail that we're using for the vertical part is about 200. The carriage for this linear rail is I don't know, 20, 30, and we're also losing 30 from the grabber section, and then we're also going to lose some from the top section. So like, okay, now we're getting into like the sketchy territory, right? So what do we do? I mean, also there's the limitation of the length of the actual aluminum extrusion that I have. Because I only have so much. I have, these aluminum extrusion lengths are 220 millimeters, meaning I only have that much vertical space. And if 100 of those millimeters are being used for bin, and then another 50 are being used for like the mechanics, and then another 50 are being used for just being wasted, because it needs to be part of a frame too, then like it's hard. So what we can do, we can pop into Fusion 360, wow, and check it out from here. Now, hypothetically, as long as I take the distance from this plane to this plane, 30 millimeters, we will have always more than this space. Now, okay, there's another point where I need to worry about. Let me get back to my Microsoft Paint. Here's the other point I need to worry about. So we've got the bin, right? And then we go up from the bin, right? We have to clear the bin on the way out. Meaning our space up here is even more limited than before. So yeah, it's a bit tricky and complicated. So what do we do? I don't know. I can also put it on this face. There's nothing stopping me from putting it on. Oh wait, no. This entire area will be blocked by the badge holder that we're using as our spring. So we can't put it here. We can put it here. We can put it here. We can't put it here because this part is the linear rail section. I mean, could I put it there? Maybe. Should I try? Maybe. I could always embed it into like this. This could be where the like pivot point is on this face somewhere. Like I can have it in there and then the like it'll poke out here or something. Like it could poke out to the side here. It could just be like that, and then the part that blocks it could be attached right here. The only problem is that this is this here is print in place, and this is the plate that's supposed to be on the bottom. So what I could always do, I can have a screw here, and then I can attach the hook to the beam that rotates around here. So it would look something like this. That's a screw, right? And then I can just have the beam like this, right? And then, no, maybe the beam would be something, maybe, oh, here, this is what the beam will be. It will be like this, right? And then this can be where the dot can be like here, right? And so that'll help solve the problem. And also these can be on different planes. So like this screw can be here, the hook can be here, and then this dot can be like here, right? So that's what we have to do. Isn't that fun? Also remember, we also have to make it such that this beam can be pushed to that way without much stress. So, wish us luck. I think I will put it right about here. I think that's a good spot for it because I've got space here, I've got space here, and it also is not the part that like interfaces with the card and the side of the bin, which means, you know, very good things. Also, this part is thin, so it will be easier to like attach it somewhere because it can stick out a little bit. Of course, does that mean that it could also be very flimsy and break? Yeah, it could be very flimsy and break. Also, I mustn't forget this. I need the spring that brings this up and down. Last time, I had a screw here, and then screws here on this to have the rubber band like go down like that, and that'll help push this part up. If I'm doing it over here, how do I do that? Well, I don't know. What I can always do, this is an option, I can always just place a spring in here, right? Just like a normal ordinary pen spring. Now, do I have a spring like that that I can easily and cheaply acquire multiple of? No. I have magnets. Should I try magnets? Where are my magnets? I was playing with them yesterday evening and I lost them. So good job, me. Very good, very good. Where did I put them? All right, pro tip, guys. If you have magnets and you plan to use them in a project, don't just play with them and put them on your table somewhere. Oopsies. Like I thought I put them on the ruler. They're not on the ruler. I thought I put them on this like breakout board thingy. It's not on the breakout board thingy. So where could they be? Good job. Good job. All right. Great. Okay. Springs. We need springs. Springs. All right, let's see. What do I have anything that I could use as a pretty standard spring though? I don't. You see, the thing is, I wanted this thing to be able to be made like by anyone with like the minimum amount of like very specific parts. The only very specific part that I have in this is the actual suction cup itself, which, I mean, that's kind of like you have to order it on Alibaba, but it's like an $8 part or something, so it's not that bad. Of course, that was pre-tariffs and I haven't checked the price afterwards, so I mean, I don't know. It shouldn't be too difficult to adapt it to various other types of suction cup though, so I'm not too concerned. All right, spring. How do we do the spring? Let's figure the spring out first, and then we can figure everything else out. So what I can always do is I can put the rubber band attachment there, and I can put the rubber band, well, no, here, well, here's what I can do. I can put the rubber band attachment here, like here on this face and here on this face. And then, so like I can put it up here, and then over here, and then I can have a channel through here so that the rubber band doesn't get like snapped around this like point, which could theoretically work. That might work, but also this might be too skinny compared to this side, because this face worked perfectly fine on the previous design. It was perfect. It's literally no failures. Like, it worked exactly as I intended it to. So I need to recreate that, but with the limitation of not actually having that much space anymore. So let's do that then, shall we? Now, something I can always do, is I can have a little bit of a layer for the spring, and then I can add another layer for the actual like tilting mechanism I was talking about. But yeah, it's a complicated problem, and I'm not the most experienced person in solving these types of complicated problems. Like, where do you put a rubber band? I can always put the rubber band there and the rubber band there, and it can go through here. That's a pretty decent solution, I'd say. You know what? Let's do that for now. I'll put one here, and then I'll add a channel in through there so that it doesn't break anything. And we'll see if that solves the problem. It might just work, right? Actually, I might embed it a little bit further, because we're also gonna have the swing arm here. So if I can like cut a little channel in through here, and then, well, maybe a channel in through there is not good, because I need this face to be attached to this face, so that wait, is this one body? Uh-oh. How's this one body? Oops. When did it create one body? Was it here? No. Was it here? No. Was it here? No. Was it here? No. What here? No. Here? Yes, it was here. Okay. So if I go back here and I hide, I think I'm editing body 3. Yeah. All right, let's go back to edit this, and then we can hide the one we don't want it to be attached to. There we go. That fixes it. Now we have our bodies back. Great, nothing broke, and we have our bodies. Wonderful. Okay, what do we do? Okay, let's see. All right, think. Unfortunately, thinking is hard. So let's put the rubber band in. Rubber band man. Okay, let's put the rubber band in. Let's move this out by like 4. Yeah, let's just move both of these faces out by 5. Don't need this. No, I don't need this one. Okay. and then we can put the rubber band into here. So let's create some sketches. I need to be able to see. Wait, where did my analysis go? Oh, there it is. So let's attach rubber band. Here's what we can do. We can get this down to about here, here, there, and then we can say that's good enough. And then let's just like take this down a little bit. How about we take this down the entire way? Is that bad? Yeah, that's great. Okay. What radius do we want? 5. Go with 5. Don't need that either, and I don't need that, I don't think. I guess I don't need this. That is fine. Cool. And I also do not need this. Wait, I guess I do. That's for that. Okay. Let's see here. Now what? We've got the doodad. Now we just need to put the place for our rubber band. Now, you know, the screw thing worked, so I might just do a screw. If I just went here and typed in 3. Do I want that to be... Okay, here's what we can also do. We can change this radius to be from 5 to 3. And then, or 3.5, I think. 3.5 is good. What about we did 8? 8 radius. And then this here can be 3. We're gonna actually make it be 2.8, because then I don't need to deal with, whatchamacallit? Easier. This, I need to figure out how to lock this into place here. Or I can just do that and call it good enough. Certified good enough TM. And we get a line from there to there to there. And that's filled in. Great. Now we mimic that on the other side. Could I mirror it? Yes, but okay, I will. Yeah, I'll mirror it. Need one there, I need one there. I should not have pressed escape, it takes forever. Line from the center point. That's our mirror thingy. Mirror these parts. Is this really bad? Yeah. Like this is not, I do not recommend you do this. Because it is completely like non-parametric. Like, I reckon if I extrude this, I'm gonna have some issues with faces. I didn't. Wow, this is so cool. Wow. Wait, I need to go back to that extrude so I can grab this one too. And then I need to, whoa, where did that face come from? Go away, I don't need to see that anymore. Let's just do minus, whatever, 16, sure. I have M3 by 16. Maybe we do minus 18 just for good measure. There we go. Okay, so that's where our rubber band will go. Now I just need to add the slot in here. Now I think it should be pretty simple here, because it should just be, I can just create a sketch here, And then I can just create a circle, like a 3-point circle maybe. One here, one, I don't know, over here. I don't know, we'll just see what happens. Wait, did I like clutch got it or something? Or is this just how circles work? Wait, I kind of did just clutch got it. Well, that's 30 millimeters. So what I need to do is instead go up here 30, wait, 15. And then I can just make my 30 diameter circle here. Then I can extrude this entire thing. Wait, actually, that's not what I'm extruding. Let me go back into my sketch. And then I need to get myself a rectangle from, I don't know, let's just say that to like that, whatever, that's fine. That's good enough. I do not recommend you follow along at home. This is like horrendous. If there was a competition on worst modeling, like, I would probably win it. Alright, so let's start on an offset of this, John. No. Oh, can I deselect that so I can get this point? And then let's go -5. There you go. Top 10 modeling. You're so right. But you check this out. Wow, it worked. That's so cool. That's where our rubber band goes. Oh, I should probably add a little bit of a channel here. Rubber band. You know what? We will do that. Just go here. Go get a rectangle from there to there. Finish the sketch. Go in here. You want a taper angle of some number. Go -1, taper angle of, I don't know, what is this angle? Can I measure this angle? Oh shoot, not that one. Can I measure this angle? Oh, no, not that one either. How do you do angles, chat? How do you do circles, chat? Chat, help, chat, help. I need the angle between this line and this line. No, that was backwards. What if I did this? Negative. Nope, nope. What if I did this? -13.7. Hey, there we go. Wow, we're so good at this. Is that even right? And looks right enough. Whatever. All that certified good enough, TM. Right, now we don't need to see our sectional analysis anymore. Use a ruler. Yeah, that's what I did a ruler. Yeah, okay, so that's where our rubber band goes. Figured that out. Good job, me. Now we need the weird angly bit that I was telling you about. How do we do the angly bit? Also, remember, we have the entire assembly of stepper motor up at the top of this grabber. So it might just be that I have to redesign the entire thing again anyway. It's like, let's see. This can only go so high. It can only go up until it hits the top of the stepper motor assembly, right? So I don't know what that distance is. Some number. Should I figure it out? I can figure it out here. Check this out. Boom. Maybe I can't figure it out. Don't think I'm smart enough. Oh wait, I just got a great idea. I have a ruler and I have the real thing in real life. It's about 5 millimeters. We did it. We measured with a ruler. Wow, you're right, chatter. Haunter, you're so real. I did use a ruler in real life. Okay, where was I? Yeah, Loy is so real, right? Loy moment. Okay, where was I, everybody? Where was I? Grabber. Alright, so we've got our grabber. We need to do this mechanism. How do we do the mechanism? I have no idea. Yeah, cool. Okay, here's the plan, I think. I unextrude this one. No, I don't want to I only want to extrude this face. Yeah, that sounds fine. I think I cut this, actually. Why? Why did I just cut that? There's no reason to. Is there a reason to? I need to remember why did I cut that. I cut it so that I could put my the angle mobobber like right here. But like I can also just do that just without cutting it. So why did I do that? I don't know. All right. How do we do the angle mobobber, chat? Let's figure it out right now. Angle mobobber. Help. Angle mobobber. We need rotation around a point and axes and whatever. I need language. I need the skills to speak the language that I am speaking right now. Where did I put my bin of stuff? Oh, it's all the way across my room. Give me a moment, please. Stuff ASMR. In here, in this mystical bin of mine, I have what is commonly known as ball bearings. More commonly referred to as fidget spinner thingies. So, we can use one of these to make our thingy better and less bad. Wow. Ball bearings. Yeah, I have some itty bitty ball bearings, so we can use those. I don't remember exactly what size it is, but we have the power of having a ruler. Fidget spinners were 7 years ago. Actually, they were more. They were popular in 2016, which was about 9 years ago. How big is this one? This one is 7mm by M3. I believe that M3 is M3. I have a screw. Yeah, okay, that's M3. I'm old. Time to retire my fledgling streaming career so early on. What? Alright, so this is 3mm by 3mm inner diameter by 7mm outer diameter. So that means if I attach it like right here, should be good. So let's make ourselves a sketch. Yet another sketch. Now I think I take, yeah, we're just gonna YOLO the entire thing, print it out. It's not gonna work. I guarantee that it is not going to work first try. And that's the goal. I don't want it to work first try. Well, I do. If it works first try, then yippee freaking yay, brother. Woohoo, we did it. But like, I highly doubt it's gonna work first try. If it does, wonderful. If it doesn't, that's expected. That's a radius. What is the radius of 3? 3.5. I mean, radius of 7. This is where we can put our thingy, the ball bearing, if you will. So how are we gonna mount the entire Johnson onto the Johnson? It's a good question. It's a good question. Okay, so that's a ball bearing at 7mm. So let's say 1 centimeter for the rotational bit, and then how do I like move the rotational bit? Oh, good grief! All right. Let me see. I've got a circle here. Yeah, I love circle. Circle's good. But now what? I just have a circle, and that's not accomplishing anything. We don't want the circle, actually. I lied. We are gonna get rid of the circle. Bye, circle. Thank you for joining. We want one that's 10 millimeters, and then we want it to be like yay tall or something. Okay, basically we need it to be tall enough such that... Actually, we need it to be shorter, now that I think about it. And then on the actual grabber part is where we can have the part that like intersects. Remember, we're just having a screw because it is easier. We're just gonna mount a screw somewhere in here. So it might be that I need 2 screws, or it might be that... Oh wait, I realized something. The screw can be mounted up here, and then it doesn't actually matter. I just have to have this be up at least, I guess, 35 millimeters. 35. Because I can put the indent wherever, like down here. And then I can put the screw like up here, and it will slide along until it gets boop to the point where it needs to rotate. And then it will go in, and then we will be partying. That's the goal, that's the aim. So we'll put our screw around here, I'd say. So M3, so this is 3 millimeters. I'd say that's good enough. And I'm gonna make it 2.8 so that I don't need to deal with the annoying stuff like having threads. And then how far is this distance? I need to get from this point to this line. 23, but that's at a diagonal. So what if I measured from there? That's 15. So let's go back here, and then let's measure 15 down from here. So 15 is about right here. So this is where I put my indent, is literally right there. Very cool. So let's just take it in a little bit, go, sure, 4 millimeters is probably gonna be fine. Take a line, get the tangent and whatever. Nope, that's not what I wanted, game. Let's just get closer so it's easier. Yeah, there we go, and then there we go. Cool, great. Okay, so this, and then up here is where I'm gonna have the part that the like the grabber, not the grabber, but you know what I mean, and the whatchamacallit is. Yeah, you know what I mean, right? Okay, let us get a circle, a 3 tangent circle, 1 tangent there, 1 tangent there, 1 tangent there. Then I can get a center diameter circle. This one is gonna be, yeah, you get it, right? You get it. This one is gonna be the 7 millimeters, 7.2 millimeters for the ball bearing. So we're gonna have the ball bearing on this piece. We get another 3 tangent circle at the top. You know, I could have just used slot, but I didn't use slot, so yeah, exactly. Tangent circle, 7 millimeter doohickey thingamabob ball bearing. Exactly, you got it. Yeah, I'm glad that I can be of educational use to chat. That's right, this is the most educational stream you've ever watched voluntarily. The word voluntarily is doing some extremely heavy lifting there, but because technically school online learning during COVID, that was technically streaming. Your teacher was streaming. They could have been saying, hey chat, what's up? But they're boring and stuff. Right, you're getting into MIT with this stream. Okay. Yeah, there's nothing stopping teacher to say nothing stopping teachers from saying, so chat, what do you think about y equals mx plus b? Right? Okay, let's get back to a card sorting robot. Let's see here. Professionalism, yeah, but like, you know, professionalism is boring. It's so boring, isn't it? Isn't it, bruv? Okay. we are doing a thing. The thing about this is that I need to make it such that it does not rotate. It needs to be able to, like, let me show you what I'm talking about here. Let me open Microsoft Paint. So like, it needs to be like strong in this direction, right? So this is what it is. But then if you rotate this like so, it'll look like this, right? And with the stick pointing out, it needs to be really, really strong in this rotational axis, right? Because we're applying force here. And if you know, this distance means that you're also applying torque on this joint. Meaning we somehow need to have it rotate around here while also being strong enough to not fold this way. Is this a solved problem? Yes. I'm just exaggerating it to make myself seem smarter than I actually am. Yeah, we can solve that really easily by just making it thick. Okay. We can even use 2 ball bearings. So I think that's what we're gonna do. We're gonna have 2 ball bearings, and then we're gonna have a triple. We're gonna have an M kind of deal. Let me show you. This is what our joint is gonna look like. We're gonna have 1 point here. This is for the bin, right? And then another one here, and then another one here. Then the part that rotates, the part. Wait, maybe this is backwards. I'm wondering, like, mechanically which one would be better for the actual like movement, because remember, we're just having a post that sticks out here. And so, like, actually, wait, it doesn't matter at all. No, we're good. Don't worry about it. Doesn't actually matter. But either way, I'm just worried about like a screw sticking out here and catching on the thingy. Because remember, this is where the screw will be. And then there's a nut. But like, yeah, this is where the ball bearings will go. And then our stick part will be like this, right? And then it'll have the M's, and then it'll have the M. And it'll be like that, and it'll be fine. It'll be fine and dandy. And we'll have 2 ball bearings, one here, just to reduce that like torque I was talking about. So, how about we do that? The other option is I have the M. That was horrendous. You can have the M on the part that tilts, and I think that's better because then I have these 2 thingies on this John. Now the issue here becomes, since this is what is essentially like a mega cast, right? It's like every single piece of geometry is added into one part. Meaning if one of these breaks on this big H, you have to reprint the entire H. That's not exactly good. Wait, oh, I just realized something, chat. Look, we have it right here. We have our solution right here. It's so easy. I didn't even think about it. We can just build it into, we can build this M, instead of it being an M, here, watch this. I need to make a new one because it's full. It can just be this. Right? In the floor. And then the screw goes in through there, and then it's like all good. So it's actually not a big deal. Cool. Great. Wow. We figured it out, everybody. Okay, let's do it, shall we? I actually need to undo this entire sketch now because I just realized something. Okay, let's re-begin from the beginning. I would like line from there to there. I would like a circle, as they say in Great Britain. Circle. From there to there. I would like it to be about 5. That gives us our rotational axis, right? Then we don't need to worry about it. No, I'm just kidding, I jest. We need tolerance, is what we need. Tolerance is important. Maybe not 5, maybe 6. Wow, look at that. That is a circle, if I've ever seen one. Cool. You know what I realized? Maybe I'm doing this on the wrong face. I think if I start from this face, it'll actually be easier. Because these slots don't have to be perfect. They can just be fine, and then it's all fine and dandy, right? So what if I just made it such that these slots are where you just push the ball bearings into, and then the ball bearings just sit in this, because here, okay, let me draw this out again. Here we have this, right? So I have 2 options for the ball bearings. The ball bearing, option number 1. This is the part that rotates, right? I can put the ball bearing here and then the screw through that. And then the inside of this screw is attached rigidly to the bin, right? So it's like this, and then there's the M for the this, and that goes into here, and it rotates around the ball bearing, like where the screw is not the like static part. Option number 2 is I put the ball bearing into like the base, like that, and then the screw goes through that into this part that rotates, right? Where then it becomes like this, right? Where you have the M there, screw goes through this, and then this is all floating. That's floating, this is floating, and this in the middle is floating. Now if I do this way, I don't need the M, I can just do a rectangle. Wait, that's so much better. The only problem about this is that then you have to have clearance for the entire screw to go through, right? Because that's the screw. So you need to be able to have the screw go through the ball bearings, and then here's the part that rotates, and then the screw can't touch anything else, meaning that the entire like locking force on the screw is in this. That is the part that holds the screw in place. Now, can I embed like a lock nut into there? Yeah, I could try that. That's an option. Should I try that? I mean, do I have any on me? Let's see, in this bag, is there one? No, that's M5. It's all M5. No, wait. That's M5. I don't have one. Good job, me. Good work. You know what? This is the fast, cheap, and dirty one. We don't actually need to make it perfect. So we will make it fast and cheap and dirty. That's... Oh, wait. I don't want to actually close that. It's very useful. So, what do we do now? We've got our idea. We're gonna have where I'm gonna do the floating screw, because I think it's better technically. Like technically it's better, it's a better solution. But how are we gonna do it, right? How are we gonna implement that? Because then we need a way to keep those ball bearings in place within the structure without them being attached to the, what's it called? Which then becomes like, okay, how the heck do you do that? So like, I can think about it. No, let's see here. Let's see here. Considerations that need to be made include. Maybe we don't do it this way then. Maybe we do it the other way. Let's get back to this. Maybe we do it this way. This way seems easier. It just might be less reliable. Dang it. If only I had like a mechanical engineering like bachelor or something. Bachelor. I would go crazy right now. I know the solution. I know which one's better, but I don't know which one's better because I don't know the solution. Anyway, we're just gonna start putting it in a random spot and call it good. Yeah. How does that sound? We need a rectangle. Only I had a degree, am I right? Chat. All right. 18.5 by 10. That is the size that we are allotted. All right, let's see. Let us see. Rectangle. We need ourselves an M. And we also need to consider like how far off from this is it. So how about we give ourselves 3 millimeters for the no, that's not 3 millimeters. It's a bit more than 3 millimeters. I mean, I can give myself more than 3 millimeters. There's nothing stopping me from doing that. That's a circle. All right, let's get 3 millimeters for the ball bearing. Then we're going through the you know what? No, we are gonna give ourselves we're gonna give ourselves 4 millimeters for the ball bearing. Wait, I need to think about this. How did it work again? I forgot. Ball bearing goes into the part that rotates. And so we need enough space for the ball bearing to slot into the part that rotates. So I think giving myself 4 millimeters here. Nope, that's not it. 4 millimeters by, what was it, 10? Yeah. Then this one can be 4. That's not 10, 4. 10, 4, good buddy. 10, 4. Then, so this will be where our Johnson goes. It is 12 by 10. I think that's good. And then this part is where the screw goes in. So that means I can go here and I can extrude these slots down. Like, okay. And then here, I can create a sketch on this thing. And then I can just get a line, triangle, triangle, circle, triangle to circle, 3. Click finish the sketch, press the E button. EA Sports, it's in the game. So right. Do that. Then I need to see that sketch again. So that I can do this. Let's just go. Sure, 14, that's a good number. It really doesn't matter because I don't know. And then I also need to go here and I need to create countersinking for the screw. So that's, I think it's 7 millimeter diameter. So we'll grab this. We'll go in about 3. There we go. Check that out. Boom. Wow. Doesn't that look so professional? Incredible. Okay, where was I? Where was I? Okay, we need to do our arm. The arm piece. Remember the arm piece. So, let's start the arm piece from here. That's a good spot, I think, for it. So we want to get a circle here. We're going to give ourselves 10 millimeters. 10. Yeah, very good. Then we get ourselves a rectangle. From there all the way up to here, I'd say. Seems like a good spot for it, don't you think? Maybe it's not a good spot. I don't remember. I figured it out earlier and then I forgot. We're gonna go here, I think. Yeah, that seems like a reasonable location. Then we can create our circle for offsetting the thingy. 3. We're actually gonna make that 2.8. I'm just redoing what I did before, and then I take a line that's 15 down from here, so literally right there. And then I can get myself a slot, center to center slot from here to, we're gonna say that's probably fine, 3 millimeters. No, we're gonna make it be 4 millimeters. Well, that good. And then I have a secret strategy. We're also gonna put a little bit of an outcropping here. Actually, it's gonna be a nice big circle-ish thing. It's gonna be a bit round so that just because. Okay, we can trim some stuff that we don't need anymore, like this and 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 this. There. And that. Don't need those anymore. Oh, and this. Bye-bye. Cool. So this will stop it from going out. So like this will lock it in place. Like it won't let it go out of the assembly, right? Because you don't want that to happen either. So that'll hold it in place. This will lock it in when it is, you know, done doing the thingy. So now we need the place for our screw. I'll put it, let's just put it in the middle somewhere. It doesn't really matter that much. You know what? Yeah, we'll put it there. That's a good spot for it. 2.8. Wow. Finish the sketch. All right, now we can extrude this body. Hold on, let me grab these. Oh, I forgot something. Hit cancel. Go into here, and then we need a circle that's 7 millimeters in diameter. We're gonna make it be 7.2 so that the ball bearing actually fits. But yeah, we need that. Then we can extrude this entire segment. Yeah. Into a new body. About 4 millimeters. There we go. Cool. Look at that. Ain't that crazy? Okay. Then we create a new sketch here. And then here, we're gonna make another circle. I just need to add some tolerance to those sides, but that's not too difficult. We're just gonna make it the easy way. Here, I just need to add a bit of a circle here. And then I need to add a bit of a circle here. Circle. Let's go with a 3 tangent circle. Then grab this line, and I can't grab that line. So we're gonna make another line out here. No, I need to get a line like this. We're just gonna slap it there and call it good. It really doesn't, nope, I didn't want to add that second one, but we want this to be a tangent to this, and we want this to be horizontal, and then we want it just for good sake, we are gonna have it be there, and then we're also gonna have it be perpendicular to here, just cause, oh, Okay, never mind. It doesn't really matter. But I can grab myself my circle, my 3 tangent circle, grab 1 line, grab 2 line, grab 3 line. Boom, check that out. Wow. Finish the sketch. Extrude the sketch. Let's have it go out. No, I don't want that one. That was why I made that circle. And have this go out however many millimeters it was, 4. Join, we can hide these 2 bodies. Yeah. And then I can hide whatever this Johnson is. And then I can just extrude this along with this face. Wait, I can extrude this. Start off on this. Actually, wait, here's what we can do. Instead of extruding this one 4, we extrude it by 8. Like that. And then we can extrude this face. Start object here. Distance -4. There you go. Like that. It's easy. Wow. Ain't that cool? So we have 2 slots for ball bearings, and then we then I need to actually add another sketch in the middle somewhere. So let's just put the sketch here. I need a circle. I need this to be about 3.7 or something. I'm gonna make it be 4 for good measure. 4 is a good number, right? Finish the sketch, extrude it from that, and have it be -0.5, and then hit OK. And then we're gonna extrude this, start offset, or start here, and then we're gonna extrude it -0.5 there too, so that our ball bearings stay in place. Up here, that's where it will slot in. I think this is perfectly fine. There's one thing that I would like to consider doing though, and that is taking this, adding another slot to it. Center to center slot. We'll just go from there to like here, that's fine. Make this be, let's go with 7. 7's a good number. And then if we finish the sketch, extrude this by -4. That's for the head of the screw that is attached to the thingy. And then this is for that. Cool. Actually, you know what I need to do? I need to figure out where I made this face. That was over here. I need to go back here so that I can create a big circle. A 2-point circle there and there. Finish the sketch. And then go back into my extrusion where I made this face with this one. Okay, let's not do that. You go into here and grab this too. There we go. Okay, why did it be cringe? Whatever, we're just gonna do this. Problem solved. Wow. So, what is this? Abomination? This is the thingy that I was talking about earlier. Wow. Let's see the entire thing together in one piece. Looks like that. Oh, I need to figure out where I made that sketch again. Which one was it? It was this sketch. Which sketch is this? 36. I need to extrude this in somewhat. We're just gonna go -20, just because it feels good. Oh yeah, that reminds me again. I actually need to cut this slot out here. Create another sketch here. Then you see this slot that's down there. I need to continue it. So this is 3. So this is 3. We need to go 3. Oh wait, you know what? We have a tool for that. It's called offset. -1.5. I would like to grab specifically this one and this one for 1.5. Click OK. And then we can extrude this in -4. There we go. That slot is for the head of the screw. I can hide my sketch now. Alright, what if I printed this? What if I just printed this? What if I just said send it and printed it and called it good, you know? Like, what happens then? Okay, there's a couple of things I need to do before I print it though. I need to offset this, offset that. I need to offset these 4 corners a little bit. Because I didn't put any, what's it called? Tolerance in there. I just, like, let it be. Let it be, let it be, let it be, let it be, let it only, whatever, let it be. Okay. Where was I? Screw goes there. It locks in when needed. The real issue is like, how do I make it not lock in when I don't want it to lock in, right? Because like, what if it just locks in accidentally and messes everything up? Here's how I can do that though. I can solve that problem by just making sure it never happens. That sounds like a plan to me. Oh, right. I need a spot. Oh, wait, no. This is so that I can have an adjustable, like, mounting spot for the, Oh, you're so right. I need an anti-lock. You're so right. The anti-lock would go crazy. Where was I? You want to know something cool? In a way, this channel that I made solves the issue of the torque problem. Wait, no, it doesn't, because it'll torque in this in the other direction, and it'll rub on this piece. Actually, that's fine. That's fine. That's fine. We can have that rub. That's okay. Maybe I send this, maybe I send it, maybe I just print it and just see what happens, right? Rapid prototyping in effect in real life. Like, what happens there? Nothing bad happens if I just print it, right? There's a couple of things I need to do for tolerancing, but I can just do that right now. Press pull this face, this face, this face, this face, this face, this face. We're gonna make that be minus 0.3. I need to press pull this face. 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 Minus 0.1. I need to hide this body. This one should be fine now. I need to press pull this face. I need to press pull this face. Oh, no. Press pull this face, Can I not select multiple faces? Why is it not working there specifically? Thank you, Fusion 60. Press pull this face. Can I shift? No, that's not what I want to do. Fusion, cancel. Why is it being quirky now? I selected the faces first and then I click press pull. Boom. Okay, there, that works. Minus 3. No, we're not doing minus 3. Minus 0.7. Seems like a reasonable number if you ask me. Okay, we're gonna do minus 2. No, minus 1. Yeah, that fixes it. And then that's fine. This is fine. I need to press pull these. So we're gonna grab this. Okay, I can't do the thingy again. So wait, how long is this part? 20. We're gonna leave that. That's fine. So I need to press pull. I need to select this one, this one, this one, and this one. Press pull. Minus 1. Actually, what if I did minus 2? Yeah, we're gonna do minus 2. Maybe it has to be -1. We're gonna make this one be -1 actually. Okay, next up. What else did I need to press pull? Caps lock. I don't want caps lock. I believe I added tolerance there. Yeah, I did. 0.2 mils of tolerance there. This is fine. This is fine. That's fine. This is fine. This is fine. This is fine. Okay. Maybe we just hit send. Oh, you know what I need to do? I need to take this piece and this piece. I need to hide this, and I need to cut these out. Because that ain't printable. I mean, I might add just a little bit of support for this anyway, but send it, send it, send it, send it, send it, send it. Do we send it? Do we send it, chat? Is there anything I forgot? I feel like I forgot something. I feel like I've also got it, you know? You know what I mean? I feel like it's perfect. What if I just did it? Like, press the... I mean, like, okay, I don't know why I'm stressing about this. It's just like... Okay, let's just send it. We're just gonna print it. You've been clocked out. Fair enough. I was printing something for a friend, so that's why I have so much random stuff. File. New project. There we go. Gone now. Okay. Let us send this to the printer. Okay, which part should I print first? Here. This piece will have to have support. That's okay. I can do that. For ease of manufacturing purposes, I'll just put support. Enable. Nice, let's see what happens. Looks good to me. This will take 1 hour and 37 minutes to print in PLA. I'll just print all the parts at once. It makes it easier. Let us go into prepare. Print this piece. Click OK. No. What? It cleared the build plate thing, you. Alright. Preferences. Alright, we're gonna close this. We're actually gonna close it and open it again. That always works, right? Mons, how long were you watching? Did you leave and then come back? You missed out on all the fun rambling and boring stuff. Can we make it big again, please? Thank you. Alright, let's add this. It cleared it again. How do I tell it not to clear it? I don't know how to use Orca Slicer. No, it's okay. I don't really care. It's okay. It's not a big deal. Like, everyone's busy. You don't need to watch me for 1 hour and 28 minutes. That's okay. But if you want, I can walk you through the finished part. As of right now, at least. This is what you've got. Ah, look at that. Isn't that cool? So this is where our end stop will go. I just made it like that so that I can adjust where it goes up and down. Because I figured it would be easier. This is our belt location. I did the mathematics and it should line up. This is the part that we made today. We added this. This is... I think I deleted it. Yeah, I deleted it. This is that thing, that hook that I was telling you about earlier. Basically, it goes up, And then once this lets this go clear, it can go to the side, and then that'll lock it in place, and then we unlock it on the way back up. This is for that screw. This is just for an M3 by some number screw, and then there's bearings there. And we also added a rubber band channel. So rubber band goes there, and then it goes underneath into this. Now I'm worried that it might not be like taut enough, you know. Like, what if it's not like... Wait, I can just measure it. I have a rubber band right here. Okay, what is the distance we need for a rubber band to be taut? And then I can just count the lines in. Okay, a rubber band is taut when it is stretched to 80. 80 is about how far it needs to be. So how long is this? This is 21. Oh. Well, I can double the rubber band. Cool, 21. Yeah, that's a good number to have. I mean, there's a little bit extra there and there, but you know, or I can get smaller rubber bands, or I can just say it'll be fine. Oh wait, maybe, okay, maybe I think I grabbed the wrong one actually. I'm looking for this line. The length is now 23. Good. Oh wait, that's only half. That's only half. So it's actually a total of like 50. And then I think the length from that to this is like 10. We'll call that roughly 10. So then that's 60, 70. And then with the radiuses and all that, radii, it'll be a little bit bigger. I think it'll be just on the edge of good enough. Cool. We did it. A star for me. Okay, let's see. Let's print it. We're gonna print it. It's not gonna work. And yeah, it's certified good enough. We're just gonna print it and we're just gonna like see what happens, yeah? How do I like add objects? Nope. Wait, what is this folder? Oh, this is all my Fusion 360 stuff. Wait. Okay, why did it clear the build plate again? How do you use this software? No. What? Huh? 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 What? What's going on? Why? Okay. Yeah, Orca Slicer is just like it's an open source fork of Bamboo Slicer. I mean, granted, Bamboo Slicer is also open source, but this is just a fork of it. Orca Slicer, multiple models on print bed. Cool. That's not helpful. Okay, let's see here. I want to click the add button and I want to click body fix 3. Okay, and then it clears the build plate and then it puts it back in. Why can't you just let me put another one on it? What is going on, dude? if I got rid of the build plate? What if I got rid of that? Go into here, go into preferences, and check that. Wow. No. I am English, yes. I'm British in it, bruv. Is it this? Oh, curious. Sure. Check that. Yeah, okay. We're gonna close it and open it up again. Yeah, it's because Bamboo Slicer is a fork of Prusa Slicer, which is then a fork of Slice 3er, and then Orca Slicer is a fork of Bamboo Slicer. So, yeah. All right. They're gonna. Ooh. Yes, it worked. Hallelujah. Okay. Rotate this one. Place it on. No. Place it there. Alright. I need to do objects. Body 3 needs support. Body 6 does not need support. I designed that one to not use. I mean, I might add a little bit of support anyway, just for this specific curve. So let's do that. Enable support, normal manual, and then I will paint it on right here. There we go. No, I don't need, well... Whatever, that'll be fine, right? Okay, cool, we'll call that good enough. And then the last little part. The last little part will also need support. This is a pretty not well designed part for printing, I will be honest. I did not optimize for printability. I just optimized for ease of making everything else. Alright, put that there. Rotate it like this. And then I need a little bit of support on this Johnson to enable the support. Slice it, see what happens. Yep, that's what I wanted. That's what I wanted. And then this is ugly, but that'll do. Yeah, that'll do. Okay. It'll take 2 hours and 41 minutes. That is not that long. So I can go and do partying stuff, and then I can return and see how it fits together. And then tomorrow, I'll have a stream in the afternoon, maybe. Well, afternoon for me. Really late in the evening for the people in the United States. And then I'll see how it fits together. And who knows? First run? Do we do the Arduino firmware tomorrow? I don't know. Well, I can't. I don't have the wiring done. Don't have the whatever this clicky thing is, end stops set up. Like, I need to print the end stop thingy. Clearance? Yeah, the hinge has clearance. It has 0.2 millimeters on one side, and then like it'll be fine. Well, maybe it'll be fine. I don't know. Here, let's see. Will it be fine? Because there's a little bit of clearance there. Here, let's just click M and rotate it around this. Let's rotate it. Can I not like see it in real life? Oh, I don't want to move the face. Can I move the body, please? That's what I select. All right. Oh yeah. Oh yeah. No. That's plenty. I think minus 15 is about right because that's where it is. Yeah. 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 There you go. There we go. That's lining up. Maybe I should have made this a little bit bigger. You know what? We will add a little bit more of a, you know, tolerance there. So let's just go distance and angle. Sure, we'll call that good enough. I don't know. I didn't mathematic it. I didn't calculate it. It's just good enough TM. Okay, where was I? We need to reprint this thing now. So I can go to prepare, remove that, make this, send it, import geometry, and then I need to enable supports on this, rotate it around the green line. There we go. Place the plate. Looks good to me. Send it. 2 hours 41 minutes. Okay. Yeah. Okay, I need to change the filament. So I will be back. Wait, Almonds, have you seen my my loading in screen? I made a cool loading in screen. Hint. Cool. Okay, if you want to see it, here, it's this. I'll show you. I set it to automatically mute me whenever I click it, but here. Wow. Yeah, so this isn't really a BRB. This is more like a wait, unless you are talking the BRB in Microsoft Paint, in which case I don't remember. I never watched like Wolfie live, but yeah, this is my loading in screen. I don't actually have a be right back screen. I can make one though, but like I think drawing on Microsoft Paint saying BRB filament change is more fun. Anyway, BRB. Okie dokie, filament loading complete. Now, I get to click this button, and then I get to click this button, and then I get to click this button. I don't think I need to level my bed, it's probably fine. And I get to, click this button, and then I get to click I get to type this into my keyboard, and then I get to write on this. Hold on. I get to write on this. Think you capital 4 number letter number for watching. Yay! I gotta squeeze a third one into there somehow. Okay, thank you for watching, everybody. I hope you had an enjoyable streaming experience. I know I might not be the most I know what I talk about can be a bit dry, but try my best. Anyway, thank you for watching. I will see you again, maybe tomorrow afternoon, maybe not tomorrow afternoon. It depends. Right, I need to tell you about a little bit of a story. All right, we're gonna do a bit of story time. Story time. All right, we're gonna do a little bit of story time. Actually, I lied. We're not ending it just yet. Story time. Okay, so you might know I am employed now. So, my employment is teaching kindergartners how to, teaching kindergartners English. And what that means is that I, instead of having my first, but it's a word. Gosh, I am so bad at the English language. Holy cow. My first shift, that's the word I was looking for. My first shift, instead of it being tomorrow, as was originally intended, it was Friday evening. That was my first shift, yes. And it was substituting. And oh my goodness, guys. Those kids. They're crazy, man. Like, wow. I wish I was that energetic. It was going mostly fine, I'd say. They were very engaged in what I was saying. Until, I was teaching them the letter Z. 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 Z if you're Canadian. Z if you're normal. They're foreign kids? No, they're local kids, actually. They're kids from around here. Yeah. Kids in Taiwan, Taiwanese kids. I'm teaching them English. And so we were on the letter Z. Z. And the drawing that the people had, like the organizers, the head curriculum people, they chose to put zombie. instead of zebra, like the, you know, normal one, they chose to put zombie on the side of the letter Z, because there's a big page, there's a page with a big letter Z, and with little dots so that they can follow along and figure out how to write the letter Z. And so they add a little coloring picture on the side, and that coloring picture was, oh, okay, I can't do that, so that's great. I wanted to turn, I'm gonna go get the light on real quick, because then you can see better, and it's better to see better. Okay, there's the light. So we were on Z, right? And the picture they chose for coloring on the side of the, like, instructional section was a zombie. They wrote zombie there. And you might be thinking, yeah, that's a pretty wholesome little chill thingy to put for kids learning how to write and speak in English. Until you realize that once they see the word zombie, they're gonna want to try and pretend to be zombies. And since they're pretending to be zombies, right, that means they're walking around the classroom and, like, with their arms out chasing the other kids. And it's like, okay, right. And then the kids that are getting chased start screaming. And then it's like you just set off a loose cannon. It's like a bull in a china shop. It's horrible, dude. It's like, okay, what am I supposed to do? What do I do, right? I mean, I had to get the, because, like, once again, this is my first time doing this entire thing. I don't have, like, the experience to deal with children running around chasing each other as if they're zombies, and playing with the toys from their backpack, and picking up random stuff from the classroom and playing with that too. And I have to deal with all of that at once. I'm like, what the heck do I do here? And so I had to go and get assistance from the, like, yeah, I'll admit I was completely out of my zone there. I have no idea what I was gonna do, so I had to get help from the person who, like, ran the entire place. So eventually, you know, it all got settled down. I don't know how. I think what it is, I think my biggest issue is that I don't have enough, like, authority. I don't, like, the way I speak does not, like, command authority, right? I just, like, talk the way I do, right? And it's not like, I'm not, you know, I'm not, like, yelling at the kids, right? I was just, I'm speaking with my indoor voice while they're using their outdoor voice. So maybe what I need to do is figure out how to use my outdoor voice indoors to get these kids quiet, right? But then again, like, part of the joy of being a kid is being loud. I don't know. It's like, at what point do I let it slide, and what point do I, like, you know, have to rein it in, you know? And I need to figure that out before I get demolished by these kids in the tomorrow, actually. Tomorrow morning is my first shift of being a real, like, doing it, not just substitute. And so I do that for 2.5 hours, 3 hours, something like that. But luckily, I'm gonna be the main person for the mornings, at least, right? So that means I can do all of those techniques that they like to say. How many kids? I have no idea. It was like 13, 14 last time. That was too many. I died. I didn't actually die, but it was a lot, and I was cooked. So, yeah. And yeah, it was a lot. But luckily, I'm gonna be the main lad there, right? I'm gonna be like the numero uno. And so I'll be able to teach them the stuff like Quiet Coyote or whatever. I can be like, hey everybody, Quiet Coyote, this one is Quiet Coyote. If I put this one up, that means you put it up too. And if everyone puts it up, then we're quiet and stuff. And that's good, and and you don't actually have, like, a real reason to want to do it, and I'm just hoping that you have a reason to do it, because if you don't do it, then the class will become chaotic and horrible, and I don't know what to do after that. So I have a resource that I can read. Okay, look. The resources they gave me, it's just the worksheets and, like, a little instructional booklet of how the date goes. They don't actually tell me how I'm supposed to control the classroom, right? I need to do that research myself. And let's just say It's a lot of reading, and I haven't looked at it yet. So maybe that's what I do this afternoon. But anyway, that's story time. I hope you enjoyed it. I'm gonna scroll back up this page to the thank you for watching. And I hope you enjoyed the stream. I don't know. I thought it was fun. Had a good little short one. We got the print started. We're finally doing the grabber. I think once we finish this grabber, I think we can finally start doing the electronics. Wow. But first, I'm gonna have a little bit of a surprise stream. It's not gonna be a card sorting robot. It's gonna be something completely different. We'll have to find out on the day of. Wow. Yeah. So I hope to see you very, very soon for this surprise stream. You'll see what it is, and it will be very useful when we are doing the electronics and the assembly of the Johnson. So I'll see you later. Thank you for watching. Bye bye.